Good afternoon, everyone. Thank you for taking the time to be here on the last day of the conference. I know it's been a long 3 days, so thank you for being here. My name is Chris Sciarrino. I'm a solution architect with AWS, and with me is my colleague, Matt.
So I'm Matt Bruno. I'm a container specialist at SA. Nice to meet you all.
And today's talk is going to discuss how do we think about building a zero trust architecture in Amazon EKS, or Kubernetes in general, specifically focused on how do we secure workload identity and communication. Now, before we dive into the content, a quick show of hands. Who here is using Kubernetes today? OK, good. You're in the right talk. Who here is using a service mesh in production? Less hands. OK. And who here has heard of Spiffe? OK, that's about what I expected, gradually dropping off. And this aligns with a lot of the challenges that we're facing in securing Kubernetes environments today. Workloads running in Kubernetes, microservices in general, they're ephemeral by nature. There's a lot of them. We might be facing hundreds or even thousands of pods in our clusters. They're spinning up, they're spinning down, they're being recreated on different nodes, different IP addresses. And the way we typically secure these workloads in traditional systems with IP addresses and network controls does not scale with this type of ephemeral nature. Makes it a lot harder to do. And this is why shifting to a zero trust mindset and architecture is so important, as we take the trust out of the network layer and the network controls, and we shift that to something else. And today we're going to talk about how do we shift that control, that trust from the network to identity, which is going to be foundational to us having a successful zero trust architecture. Now, here at AWS, how we think about zero trust is not from a product perspective. We don't believe there is a single solution that you go and you buy off the shelf and you put it in and now you have zero trust. But it is a security model and mechanisms that moves us from a network focus or network perimeter security controls towards having, or not just solely network perimeter, but towards having other controls. And today we're going to focus on identity, right? So moving from the network to also including identity. Matt, can you take us through a little bit more about some of the common challenges with securing workload identity?
Sure. So the first question we always get is how can my workload, especially running in a Kubernetes environment, can establish their own identity? A lot of people actually go to SSL certificate or TLS certificate. As we know, there are probably more X509 certificate, but when you can manage maybe tens of them by hands, no problem, not too much problem. But when you get to hundreds, if not thousands of them, there's a lot of day two operation. The actual goal is also to make them as short-lived as possible, so that actually adds a lot of management to it. If you were to replace them by hand every hours, nobody will do that. Interestingly, inside of EKS specifically, the Amazon Elastic Kubernetes Service, we do have mechanism to inject IAM roles, so we'll see that in a couple slides, to your pods directly, so they can use those IAM role as their identity when they reach to AWS services. And the question we always get is how can I enable trust across different organizations that are kind of separate, or even inside different business units inside of the same organization. So today, we will focus on two service identity big aspect, right? So you're all familiar with the AWS IAM roles. We'll see how we can use this to access AWS services from EKS pods. And we'll also talk about Spiffe, the universal standard for workload identity. So I'll start first to present the Amazon EKS pod entity. So this is a service that you can use to connect your pods running inside of EKS to IAM roles. So a lot of people in this room may be familiar with what we called HRSA, the IAM role for service accounts. So EKS pod entity has the same goal. It's just if you want some kind of a iteration over what HRSA was providing. It does come with a couple of interesting benefits. One of them is it does support IAM role session tags. So you can actually use those tags to provide fine-grained control through resource policy, and we'll see an example of that. Of course, all the call of assume role of this through the EKS pod entity is logged into CloudTrail, so you can have a nice way of following what type of action is actually being done with those. So how does pod entity actually work? So inside Kubernetes, most people start their deployment by pushing an object that we call Kubernetes deployment. So when you push this inside your cluster, it will create some type, basic object inside Kubernetes. You also all have the AWS IAM section where you can define role policy and line policy, basically permission that you want to give inside of AWS. What you also define on a specific IAM role, there's something called the trust policy. And actually, the biggest change in between the way URSA and the EKS pod entity actually works, and we'll see that a little bit later in the demo. So when you have those created, so your deployment inside Kubernetes will use something we call the service accounts. So the service accounts is a way to give your workloads permission primarily to the Kubernetes API of your cluster. But inside of AWS, so if you want to use the EKS pod entity, you can actually use that unique pair of cluster, namespace, and service accounts to link this back to a specific IAM role through something that we call the EKS pod identity association. So overall, this is really what's provide the basic of EKS pod entity for workload accessing AWS services. We do have an example here on the screen of what a resource policy for a secret manager could look like when you're using the actual session tags. So if you want to give finer control, you can use conditions, and you can specifically use details of the cluster and the resource tag that it's actually coming from. Any question on EKS pod identity? Looks like we have a couple of Kubernetes experts in the room, Chris.
All right, thanks, Matt.
No problem.
All right, so we talked about EKS pod identity for that first use case of how do we have our workloads access AWS services. But what about everything else? We have all our other workloads. We might have other services outside of AWS. How do we establish an identity foundation in EKS that allows us to do that? And this is what Spiffe was designed to solve. As Matt mentioned, it's a universal standard. It stands for Secure Production Identity Framework for Everyone. Do not ask me to repeat that. It's a tongue twister. I'm going to say it that once. It is an open standard. It's a project under the CNCF, the Cloud Native Compute Foundation. It graduated in 2022. Its main goal is to provide workload identity for distributed systems. Not necessarily for EKS. It could be essentially any distributed system, but we do most see it in Kubernetes and cloud-native environments. What it does is it provides a cryptographically verifiable identity for every workload. And I can show you how, we're going to show you how this works a little bit later on. But those identities come in either as JSON Web Tokens, so JOTs, or more commonly X509 certificates. We refer to these in a Spiffe environment, we refer to these as SVIDs, so the Spiffe Verifiable Identity Documents. The main thing that Spiffe solves for is what we call the bottom turtle problem. How do we secure the foundation of our infrastructure that we build the rest of our security on top of? Right? So when we're talking about a zero trust environment, how do we baseline our identity that we're building on top of? The one good thing an additional good thing that Spiffe does is it provides a testable workload. So I'm going to talk to you a little bit more about what that is, but that helps us solve for that bottom turtle problem. Now, before I show you how this works, there's a few other concepts I need you to get familiar with. First one is a trust domain. So in a Spiffe environment, the trust domain is think of it as the root of trust for our identity provider. Commonly, in most organizations, this is going to be a business unit, or it might be the whole organization itself, depending on the size of the enterprise. Another term that you will see commonly is what's called Spire. They're often used interchangeably, But Spire is a production-ready implementation of the Spiffe APIs. Right, so they're commonly used interchangeably. So here in our diagram, you'll see we have the Spire server in red, and that Spire server is like the brain of the operation. It is what handles the issuance of the identities. And without that Spire server, things will not work. Right, so we have our Spire server issuing the identities, pushing them down to our workloads, and with that, they're also issuing trust bundles. If any of you are familiar with general PKI, trust bundles would usually be the CA certificate that has signed the certificate that's being issued. Right, so we're pushing the identity, which is commonly the certificate, as well as essentially the CA certificate, down so that way any other certificates signed by that Spire server we can verify. And the last thing I want you to see is at the bottom there is what you'll see is a Spiffe//trust domain. That is commonly the format in a Kubernetes workload, what that identity would look like. With Spire, it is customizable, but that is commonly what it is. So trust domain, which looks like a domain name, doesn't have to be, followed by the namespace of the workload, followed by the service account. That is the template, and we'll see that as we go on. Any quick questions here before I build this out for you and show you how this works?
Does it get really painful to sort of mutate namespaces, something like this? Like, you know, migrate namespace A to migrate namespace B, but it's still the same service?
You can have templates that do the substitution for the namespace, and I'll show you that later on. All right, so as we talked about, is the Spire server is the brains of the operation. It is the main thing when you're building out a Spiffe or Spire environment. But in most enterprises, the root of trust in your PKI is not necessarily going to be the Spire server. You're probably going to have something that already exists. So you can integrate it with your existing certificate authorities for in your enterprise. I've depicted AWS Private CA. We're at Reinforce, but it could be anything. There are a lot of built-in plugins that you can use. If you are going to use AWS PCA, the EKS pod identities that Matt talked about earlier allow for that secure access between the Spire server and the AWS service, the AWS PCA. So you can use it, you're using them both together. Once that Spire server is up, every node in our cluster is going to have a Spire agent on it. And that Spire agent is what's going to do the attestation of the node. So I mentioned earlier that one of the great things about Spiffe is it allows for the attestation of our workloads. But in order to attest our workloads, we need to make sure that what we're running on is attested first. So as those nodes come up, the Spire agents get deployed. The Spire agents attest that node. In an EKS environment, it's looking for a service account token. The agent provides that to the server over TLS. The Spire server independently verifies that those tokens are valid, that this node actually does belong to the cluster. And once it's done, it provides an SVID, so it's providing essentially a certificate to the node. And then we form MTLS between them. We'll talk a little bit more about that later on, but we have secure communication now between our nodes and our Spire servers. Once the agents are up on our nodes, now as we bring up workloads, our workloads can now start requesting their own identities. This happens automatically. So the agent on the node will look at the workload, see if it matches the criteria that we have set, and I'll show you how that works a little bit later. But if that workload matches what it's set and it's attested, we now provide that we request from the Spire server an SVID for the workload, which comes from the Spire server, and we pass that on to the application, which it can use for various things. Commonly MTLS, service-to-service communication, that is very common. We're going to show you that later on. But you can use that for anything else that you can use, an X509 certificate or a JSON Web Token. Okay, so I talked about how Spiffe and Spire provide a standard for issuing identities. But those identities might need to interact with services beyond just our trust domain, might need to interact outside of our organization. There might be other Spiffe and Spire environments that we need to interact with. And this is where the concept of federation comes in. Right? So if we imagine the environment we just looked at was trust domain A on the left-hand side. So it's pushed down the trust domain bundles and the SVIDs for our environment. But if we set up federation between ourselves and another trust domain, essentially we set up an endpoint, and through configuration, our Spire servers communicate through those federation endpoints. they exchange the trust domains, the trust bundles on a continuous basis after the bootstrapping process, and we have authenticated each other. So what happens is when, let's say, service B, which is the green box on the bottom left, needs to talk to service Z, we've set up that federation. The trust bundle that gets pushed down to those individual services will have both for the trust bundles for trust domain A and trust domain B. We'll have both. So we can now validate the certificates signed by both trust domains. That was a lot. Is there any questions? Yes, I'll take a few over here. Go ahead. It does absolutely work in EKS auto mode, yes. Next question.
Does it basically mean that every service in domain A, is there a way to carve out that?
The question was, does every service now automate? If we set up federation, does every service in both trust domains automatically trust each other? The answer is no. You have to specify, like, I want this particular set of workloads to be able to federate with these workloads. And only those workloads, when they get their trust bundles pushed down, will have the particular trust bundles for the other domain. So, a few things I want to explain here first. So I have a very simple Kubernetes environment stand up. It is actually EKS auto mode. That was the question earlier. Does it work in auto mode? Yes, absolutely it does. I have a front end. I have a back end. And like in regular Kubernetes, there is automatic communication between them. There's nothing blocking at a namespace level. Can you all see that okay, or should I make that a little bit bigger?
Make it bigger.
Okay.
It's not very bright, so maybe that'll compensate.
There we go. There we go. Okay. So, like I said, simple. We have a front end, we have a back end, we have communication. But that doesn't give us any identities. Those workloads could be anywhere, any namespace. We have no way of proving what those workloads are. So the first thing we need to look at, like I was talking before, is that node attestation. Before we can give those workloads identities, we need to have identities for the nodes themselves in our cluster. Right? So automatically, and I've set this up already, but automatically you can see here we have an attested agent. So like I said, the agent on the node, every node has an agent. The agent on the node has the identity. So there is an ID here. I'm going to scroll over. You can see it because this is going to be important later. So just remember C99, okay? C99 is the Spiffe ID for our node. We can see how it has been attested. So this K8's PSAT, this is the out-of-box verification for Kubernetes nodes. It is looking at the service account token on those nodes. And we can see that it is expiring shortly. It will automatically renew itself. And we can see the serial number, and we can reattest. So that's step one. Our node has been attested in our Spiffe Spire environment. Now, there was a question before about how do we do this? Does it get tedious to do this repeatedly for every namespace? I'm going to zoom out just one so it's a little bit, so we fit everything. There's a few things. In order to set up identities for the workloads now, we need to use a resource called the cluster Spiffe ID resource. This is what is going to be able to grant our workloads identities. So when I was talking before about does our workload match any of our requirements, this is what defines that. So you're going to have a manifest file, and in this manifest file, you can see here, number one, the kind is a cluster Spiffe ID, number one. You will also see, that should be, cluster Spiffe ID. Number two, we will see here the template. So when we were talking before about do we have to define this for every single namespace, there is a template we can use, and this is what defines that Spiffe ID format that I was showing you earlier, right? Trust domain, namespace, service account. And this gets automatically substituted, and I'll show you that. These bottom two sections are really important. This is what's going to essentially select the workloads that we want to use for this cluster resource ID, right? So the first one is telling us, does it have the label of Spire managed identity equals true? And the second one is just defining our application, right? These are labels that can be anything you want, but this is just tying our workloads to this resource. And the last piece here is what's called the workload selector. And this is what helps us choose what do we want to select on how we're going to attest the workloads. So this can be as simple or as complex as you want. Very simply here, I'm saying that this workload needs to exist in the curl namespace and that this workload needs to be using an image from this particular image registry. If those conditions do not match, it's not going to get an ID because we have not attested that it meets that criteria. This is a very simple example. You can take this a step further. I want to make sure that it's running an image that has been signed, that I'm the signer of, right? No one's replaced this image. It's running on particular nodes, right? So we can take this a step further. And that, like I was saying, that is the main thing. It's not just we're not just giving identities to workloads, but we're solving that bottom turtle problem where we're attesting that these workloads are actually running and who they say they are. So once I put this in the cluster, once I deploy this manifest file, as I bring up workloads, automatically, if they meet those labels, like the Spire managed identity and that app label, Spire will start looking as like, okay, does it meet any of those other criteria in terms of the curl namespace and the image? If it does, automatically, and sorry, this is just showing what I was talking about before, automatically, it's going to get an ID. I'm going to show you what this looks like now. But before I do that, there's two things I just want you to kind of wrap your heads around. The IDs themselves are, number one, they're attestable. So think of the attestation chain. So there's the node to the workload. We've trusted the node. We attested the node. We now attest the workload. Then there is, from a PKI perspective, we can trace this ID from the workload to the Spire server back to our root of trust from a PKI perspective. Those are just two things I want you to keep in your head as we go forward. So when my workload gets an ID, this is what I can see in my Spire environment. I can see, I'm going to try and zoom in a little bit more on that for you. Number one, I can see my Spiffe ID. So it's taken my trust domain was chris.example.com.
Push it back.
Oh,
to the top.
oh, yeah, good call.
Yes.
chris.example.com, very original. But what I also want you to look at is the parent ID. And this parent ID, you'll see it's very long. But if I go to the end, it ends in C99, which was the ID for our node that I just showed you a moment ago. So we can very easily trace that this ID was running on our attested node from a minute ago. So I can show you that attested chain. This workload was running on this node attested for that this workload was running on that right node. The other pieces here, less interesting. We can just see the selectors that we had put in our cluster Spiffe ID. A little bit less interesting. The main thing here to show you was the Spiffe ID and that parent on how that links. So that's the attestation chain. The other chain I wanted you to think about was from a PKI perspective. How do we trace that workload back up to our root of trust from a certificate authority perspective? So I'm just going to show you quickly. Let me just run.
I have a kindergartner question for you.
Sure.
You're doing that node attestation because you must, or because it's a darn good idea and a good practice?
It must. We must, yeah. We need to have, it's fully, everything's.
Bouncing to the node and that's.
Exactly. So if you think back to that diagram as I built it out, Spire server came up, then the agent on the node comes up, and that is what actually does the attestation for the workload, right? So once everything is verified, only then can we start issuing identities. Okay, so what I'm going to show you here is I'm building out our chain of trust from an identity perspective now. So I've got my private CA. We can see it's issuer. It's a self-signed certificate authority. This is the root of my private CA. The next thing, I'm going to scroll down to the bottom. I'm going to skip all this. Now this is what actually gets pushed to the workload. So in that workload, you see here, this is the trust, you'll see here, this is part of the trust domain here. So my common name is my Spire server. So this is the certificate for my Spire server. It has been signed. If we look at the issuer, is my root CA. So this is the private certificate authority I just showed you a minute ago. This is my intermediate certificate. And if I scroll up to the top, this is my workload certificate. This is my SVID. And my SVID, we can see here, the issuer is my Spire server. So my intermediate authority is now signed my SVID. And if I scroll down to my subject alternative name, right at the bottom, you'll see here's my Spiffe ID. And that is where you find the Spiffe ID in the actual SVIDs. It is in the subject alternative name, and it is taking the same template that I just showed you in that cluster resource ID a few minutes ago. All right? So if we think, I'll let you get your picture there. So if we want to just think about that logically again, I'm going to scroll down and I make this a little bit easier. From a certificate authority perspective, we start at our, in this case, AWS PCA. AWS PCA is the root of trust. It signed the Spire server's intermediate CA when that Spire server was created. That's part of that bootstrapping process using EKS pod identity. Once that Spire server came up, there was that whole node attestation process, that other chain I wanted you to think about. I tested the nodes, then the workloads came up. Once the workloads were attested, my Spire server issued the certificate, signed by the Spire server, right? And you can see that full chain there. Okay. So while Matt gets set up there, so what we just talked about is how do we establish an identity foundation in Kubernetes, right? So we had our identity, we talked about EKS pod identity, we talked about Spiffe and Spire for our workload-to-workload identity that we can use. But now we need to use those identities. It's not enough just to have identities, we need to use them for something, right? And this is where we start getting into thinking about authorization, right? So we're applying a policy to those identities and moving from having implicit trust to where we want to explicitly authorize every single request. And Matt, if you're ready, I'm going to turn it over to you to continue.
That looks good.
Nope.
Oh, sorry. Forgot the part of the presentation. So common challenges that we get into authorization, right? Even though we have a strong identity now, we do have to ensure that that identity is validated on all service-to-service requests. The goal, we want to minimize the call to external services to validate those identity/permission, because we had latency challenges, scaling issues, all those kind of things. So the goal will be to have a consistent way to manage those identities and authorization across the entire environment. So what if we could, and the goal of what we talk here with Zero Trust is you want as well to validate the identity of the server you're calling, but the server should be able to validate the identity of the client doing this. And a lot of question we do get is, how do I do this so that my 15, 30, 100 different application doesn't have to re-implement the same thing? And this is not scalable. Doing this in all your application takes a lot of work, a lot of potential mistake, and whenever you need to change something, it's also a lot of work. So inside Kubernetes, a lot of people go to the concept of service meshes for this. Service meshes do bring a lot of interesting controls, advanced control, advanced routing policy. So it is really a solution that we see implemented in a lot of customers. They do also bring a couple of extra security features, one of them being encryption. We did talk about authentication since the beginning, and also authorization policy. They usually bring some kind of a service discovery as well, and kind of a layer of monitoring observability that a lot of people love as well, but this is not the main talk of today. So for service meshes, the goal is, how can I control my service-to-service access? So by using the identity that we're talking here provided by Spiffe is actually a very good way of doing this. To do this, a lot of people are actually moving to, are actually using what we call mutual TLS, MTLS. And inside of service meshes, there's a pattern that we called the sidecar, which basically allows to have a proxy running next to your application that can handle most of the encryption, authorization, work for you, so your application team don't have to re-implement all of this together. So the nice thing about Spiffe and the SVID certificate is those are actually certificate that you can use directly into your sidecar mesh for doing MTLS. So if you're not too familiar with MTLS, I'm sure everybody here is familiar with TLS. So in TLS, there's an handshake. The MTLS add basically, in the handshake, when you connect to the server presents a certificate so you can validate its identity. In MTLS, there's basically a server is asking you for a client certificate, which you do provide, and then he will validate that he trusts your client certificate to continue operating with those servers. So the trust is built both ways. So if that sounds familiar to all the SVID thing we have been talking since the beginning, you're exactly right. So inside service meshes, if we are, in Kubernetes, one of the very common service mesh that we see is called Istio. Inside of Istio, you can build authorization policy all the way to fine-grained identity provided through your SVID certificate. So we do have an example here where we're using the principles. So the trust domain here is example.com. The namespace is called frontend, and we're using a service account called checkout. But you also can combine this with fine-grained control over layer 7, method, specific path, host space. You can kind of combine all of this into multiple scenarios. How about we look at a small demo of this with Istio?
While he's getting set up there, any quick questions from the audience? Sure, go ahead.
How does this complement or work with network policies that control
No, that's a really great question. And so if I go back to my definition of zero trust before, it's not an and or, it's how do we move beyond just using network to including identity as well. So we can use network policies from a network perspective to control namespace level access, but that doesn't still prove to us, is that workload actually where it says it is? You absolutely can still use both. And you still use both. It's not one or the other, it's an and. Sorry, Matt, go ahead.
Cool. So I do have a cluster running. Somebody did ask about auto mode. My cluster is not running auto mode, but it works in both cases. So we can actually see the list of pods that I have here. So like Chris, I do have a Spire server set up with my Spire agent running on my 2 nodes. I do have also, so my Spire server do use the EKS pod entity association that we talked about to have access to my private CA authority. So let me show you this inside of the EKS console. So this is my cluster that I'm using. So if I'm going to the access tab here, and I scroll down a little bit, I can actually see my pod entity association. So we can see that this cluster for the namespace Spire server and my service account Spire server actually have a role attached. So I know this is blurred, but let me open this up for you. And we can see that role actually have the permission attached to it. So far, this is exactly the same at HRSA, no problem there. The difference comes into the trust relationship for pod identity. So if you already set up HRSA, you kind of know that we have a specific OIDC provider that's actually registered into your IAM identity provider, and this is an URL that is actually unique per cluster. With pod identity, that's one of the big change. We're using a service principal. So the EKS API is actually managing who can assume that role through that service principal for you, through what we just saw into the EKS console. And basically, when you define the role, you just link it to this service, pods.eks.amazonaws.com. And basically, that's how your pods in any cluster will have the same trust policy. So it's a little bit less management, especially if you migrate things around different clusters, those kind of things, a little bit easier to use. So if I come back to my cluster, the other thing that my cluster is running is Istio. So I have few namespaces that we'll use here. So actually, we can see the Istio running into his own Istio system. And the two namespaces that I'll be using here is the default namespace and the echo server specific namespace. We can see that the pods running in those two namespaces have actually 2 containers each. The second container is actually the sidecar injected by Istio, just like we saw in a couple slides before. Any question on the setup, or everyone saw it? Cool. So the first thing I want to show is in my cluster, so I did define Spiffe IDs, just like Chris. I use roughly the same template as him. One difference is I did not put specific workload selectors. Any pods running in my cluster that do have the specific labels of the Spire managed identity through will get an ID, basically SVID certificate. So let's look at what happens when you don't have an identity. So my first pod here, let me show the describe, doesn't actually have the Spire managed identity, right? So it doesn't have any ID. So if it calls a server, basically we will get an error from the Istio proxy, right? We can see it's actually coming from Envoy, the proxy used by Istio, and basically we do have an error is we're not able to connect. The reason for this is my Istio mesh is configured to enforce strict MTLS, and right now I'm not able to present a certificate that will be trusted by the other sidecars. So I'm basically getting rejected. So let's try the same thing, but this time with a pod that do receive an identity. So if we do a describe, we do see that we have the line with the Spire managed identity equal true. So this pod, just like Chris showed up, is getting the Spire, the Spiffe ID that we show up. And now if I call the same service, I'm actually getting an RBAC denied because I probably forgot to clean up my stuff. Let me just remove my policy here. All right, back to, let's redo that request. Oops. All right, so we're still in the pod with the specific label, and now we do get specific 200 OK, which is actually what we expect. So I'm using the Echo server. I'm sure some of you already play with it. The Echo server just send back all the data and the headers that you see from the request. So that's kind of interesting to look at. So let me just come back up. Sorry, I think I lost Spire. Oh, OK, here. So if we run this and I grab the most interesting header that we get from the Istio sidecar, so we do see we get an exported client cert here. And if we look at that very long string, we do see that it's giving us a by, which is basically who validated that specific identity. So in my case, I'm using mat.example.com as my trust domain. And basically, we're getting the Echo server namespace and service account default, which is the receiving Istio sidecar that did validate that identity. There's also a hash here that will pass. And then towards the end, we have basically the identity that was validated from the actual basically the caller identity. And in this case, it's mat.example.com from the default namespace, and my service account was called curl Spire. So that's great, but so far, we only did connect through the MTLS. We haven't actually used those identity into fine-grained control. So let's do that first. SGO needs a default deny policy, so you do have to apply it first. So let me apply this, take a sip of water, and maybe we have a question. No question. All right, so I did apply my default deny, and then I redid my same curl command, right? So we do expect this to apply correctly. Probably the policy, it takes a couple seconds for the SGO sidecar to apply get the policy push from the SGOD. So sometimes they need a couple seconds, so let's retry this. The nice thing about Kubernetes is it's a declarative system, right? So even though I did reapply my specific policy here, did not change anything because the object was already applied. However, we now see that the policy was applied, and as expected, I'm now getting a 4-3 forbidden, and basically no answer. Actually, there's an answer called RBAC access denied, which is kind of obvious what's happening. So now we can build those authorization policy by using the principle that we have. So let me apply this one, and let me show you. So inside of my policy right now, I'm using a simple allow just of the principle that I'm using inside of the echo server. So that specific curl Spire service account could now call anything, any of the workloads running into my echo server specific namespace. So let's do exactly that. So let's call the echo server on a specific URL. So took a couple seconds. We're still getting RBAC deny. So my cluster has been doing slowly this afternoon for a strange reason. So I'm now getting the 200 OK. And as before, we do see all the outputs from the echo server back, just like we had in our previous call. So is this really the best we can do? Of course, no. As we said, the SGO sidecar right now is configured for HTTPS, so it can do specific authorization, layer 7, so you can use path-based, host-based, method-based, all of this. So let me here enable the post to /API/payment, for example, in my specific authorization policy. And let me go back here. So if we were to apply this, let's wait a couple seconds for the sidecar to reload.
Yep, there's a question.
Is the policy enforced by the sidecar or the network proxy, or is it by the EKS controller?
The question was, is the policy enforced by the sidecar or the EKS controller? Did I hear that right?
The ingress controller.
Oh, the ingress controller,
yes.
sorry.
So I'm not using any ingress controller right now. So I'm doing sidecar to sidecar. So it is enforced by the receiving sidecar. That's also important. Sure, so my policy is applied. So now I'm doing a post on /API payment, right? And so we do see that we're getting a 200 OK with the same output as before. But let's say I was calling a different API this time, right? /list. I want a list of all the action available on that service. And we'll get forbidden with the RBAC access denied because the policy doesn't apply this. When you think about this, right, instead of using a list of IP address that your pods inside your cluster could potentially use, seems a much better approach to me by using the identity control that the Spiffe and the Spire framework kind of propose.
So, wrapping up today's talk, just to kind of recap what we went through, right? So we talked about why a zero trust strategy requires a strong identity foundation, right? Going back to those ephemeral natures of those workloads, not always having the same IP addresses, potentially coming up on different subnets. So moving away from using solely network controls and introducing more on identity controls. for those identities, those workload identities, they should be attested. We should not just be giving credentials to workloads. We should be attesting in some manner that those workloads are actually running where they say they are or where they should be before we give them those credentials. And then ultimately using those credentials to secure our service-to-service communication explicitly, moving away from implicit trust at a namespace level to explicit authorization for every request, as Matt showed us. If you want to learn a little bit more about Spiffe and Spire, that is a very deep concept. So there are some great YouTube videos on the left. Those first two are YouTube videos. They'll take you in a way deeper dive. And then as well as there is the Spiffe documentation as well. I would give that a read. It takes you way deeper in as well. It is a really great concept for securing your workloads in Kubernetes. With that, thank you once again for taking the time to come to this talk today. Would really appreciate it. Would help us if you filled out the survey. That does make a difference for us. Would appreciate if you did enjoy the talk or didn't enjoy the talk. Still fill out the survey. And we now open it up to any questions you have. Thank you.